The planet Neptune. Imagine venturing into the darkest corners of our solar system, where sunlight fades into a pale whisper and the vast canvas of space becomes a frozen abyss. Far beyond the orbit of Saturn and Uranus, there lies a world so mysterious, so storm-ridden, and so utterly captivating that it has intrigued astronomers for centuries. Neptune, the eighth and most distant planet from the Sun. Unlike the warm brilliance of Earth or the radiant beauty of Jupiter, Neptune hides its wonders beneath a shroud of deep blue gases, whispering secrets about the outer reaches of our cosmic neighborhood. It is a place where winds rage faster than the speed of sound, where colossal storms brew for decades, and where an icy, enigmatic core sits wrapped in layers of hydrogen, helium, and methane. Neptune is not merely a planet. It is the edge of our solar system's known giants, a gateway to the Kuiper Belt, and a sentinel standing guard on the frontier of the Sun's dominion. To understand Neptune is to step into a realm where the rules of planetary science are pushed to extremes. At nearly 4.5 billion kilometers from the Sun, Neptune receives only a fraction of the solar energy Earth enjoys. Yet, paradoxically, this remote gas giant radiates more heat than it absorbs, glowing with an internal energy that defies its frozen appearance. Its brilliant azure color, painted by methane-absorbing red wavelengths of light and scattering blue, makes it appear like a jewel in the cosmic ocean. Neptune is both beauty and beast, a planet that dazzles with elegance but humbles us with its fury. When astronomers in the 19th century predicted its existence based not on sight, but on mathematical calculations of Uranus's orbit, they changed history. Neptune was the first planet discovered through the power of mathematics rather than direct observation. This discovery in 1846 was not only a triumph of science, but also a testament to human curiosity, a shining example of how determination and intellect could pierce the veil of the unknown. From that day forward, Neptune became a symbol of both mystery and mastery, embodying humanity's unyielding drive to explore the unreachable. But Neptune is more than just a scientific marvel. It is a cosmic storyteller. Its storms reveal the dynamics of planetary atmospheres under extreme conditions. Its magnetic field, tilted far off from its rotational axis, hints at a restless interior. Its faint, dusty rings tell tales of shattered moons and ancient collisions. And its largest moon, Triton, an icy body with geysers spewing nitrogen into space, may hold secrets of captured worlds and the origins of our solar system itself. In the grand symphony of planets, Neptune plays the role of the mysterious bass, deep and resonant, often overshadowed by Jupiter's grandeur or Saturn's rings, but carrying an indispensable weight in the harmony of the cosmos. Without Neptune, our understanding of planetary science, orbital mechanics, and solar system evolution would remain incomplete. It is not simply the end of the planetary line. It is the threshold to an even larger unknown, a bridge between the planets we can see and the icy worlds that drift in the Kuiper Belt beyond. This script will take you on an extraordinary journey through Neptune's many wonders, its discovery, atmosphere, storms, rings, moons, magnetic mysteries, and its place in the greater cosmic picture. Step by step, we will peel back the layers of this distant world, illuminating both its scientific significance and its poetic grandeur. So buckle in, because the story of Neptune is not one of silence and emptiness, but of fierce winds, deep mysteries, and the eternal reminder that even in the coldest reaches of space, beauty and power coexist in ways that defy imagination. The story of Neptune's discovery is one of the most remarkable tales in the history of astronomy. Unlike the other planets, which were known since ancient times because they were visible to the naked eye, Neptune lay hidden in the farthest reaches of the solar system, beyond the limit of human vision. No ancient civilization, Greek, Roman, Babylonian, or Mayan, ever marked Neptune in their star charts. It was, in many ways, a ghost in the darkness, invisible yet exerting a subtle pull that betrayed its existence. The saga began with Uranus, the seventh planet from the Sun discovered by Sir William Herschel in 1781. Uranus expanded humanity's understanding of the solar system. But after decades of observation, astronomers noticed something strange. Uranus was not orbiting the Sun exactly as Newton's laws of motion predicted. The planet seemed to wander slightly off course, as if tugged by an unseen hand. These deviations were not random but patterned, suggesting that another massive body, perhaps another planet, was exerting its gravitational influence. This mystery captivated astronomers across Europe. Two brilliant mathematicians, working independently, set out to solve the puzzle. In England, John Couch Adams, a young Cambridge graduate, painstakingly calculated where such a hidden planet would have to be in order to explain Uranus's irregular orbit. At nearly the same time in France, Urbain Le Verrier, a master of celestial mechanics, conducted his own calculations, arriving at a nearly identical conclusion. Both men, without telescopes, without direct observation, predicted the existence of an unseen world millions of kilometers away. It was an extraordinary moment in science, the first time a celestial body was not discovered by sight, but by mathematics. Le Verrier, determined to prove his theory, sent his results to Johann Gottfried Galle at the Berlin Observatory. On the night of September 23, 1846, Galle and his assistant Heinrich d'Arrest pointed their telescope to the coordinates provided by Le Verrier. There, within a single degree of the predicted location, lay a faint, blue disk, the new planet Neptune. The discovery caused a sensation across the scientific community. For the first time, human beings had plucked a planet from the darkness without ever having seen it before. It was a triumph of reason, a validation of Newtonian physics, and a milestone in the union of mathematics and astronomy. The existence of Neptune not only explained Uranus's orbital irregularities, but also proved that the laws of nature held true even at the edge of the solar system. Yet the discovery was not without controversy. Adams and Le Verrier had both reached the same conclusion independently, but who deserved the credit? In Britain, supporters of Adams argued passionately for his priority, pointing to his earlier but unpublished work. In France, Le Verrier was hailed as the sole discoverer, given that his predictions led directly to Galle's observation. The debate became heated, entangled with national pride and scientific rivalry. In the end, history has largely credited both men, recognizing Adams and Le Verrier as co-predictors of Neptune's existence. What makes this story even more fascinating is the precision involved. Neptune was not exactly where the predictions had placed it, but it was close enough to prove the validity of gravitational theory. Later, astronomers realized that errors in Uranus's orbital data and the eccentricities of Neptune's own orbit accounted for the small discrepancies. Even so, the feat remains one of the greatest achievements in the history of astronomy, a triumph of intellect over invisibility. The naming of Neptune carried its own symbolism. Following the tradition of naming planets after Roman gods, astronomers chose Neptune, the god of the sea, to represent the distant blue planet. The choice was perfect. Its deep azure color, caused by methane absorption of red light, evoked the endless oceans of Earth. Just as the sea was a mysterious frontier for ancient civilizations, Neptune became the cosmic ocean for humanity's exploration. The discovery of Neptune did more than add a new world to our maps. It expanded the boundaries of human imagination. Suddenly, the solar system was not fixed or complete, but a dynamic arena waiting to reveal its hidden players. Neptune stood as proof that the universe still held secrets, and that those secrets could be uncovered by the power of human reasoning. It was a reminder that discovery is not always about what the eyes can see, but also about what the mind can deduce. This monumental achievement ignited further curiosity about the planet itself. What was Neptune made of? How big was it? What storms raged across its surface? What moons circled it in the cold night of space? For decades, Neptune remained little more than a faint point of light in telescopes, but its discovery opened the door to centuries of study that would transform it from a distant mystery into a planet of wonder. In many ways, the discovery of Neptune was a mirror held up to humanity. It showed us that our intellect could pierce the veil of the unknown, that mathematics could reach where telescopes could not, and that even in the vast darkness of space, hidden worlds awaited those bold enough to search for them. Neptune was not just another planet. It was proof of human potential, a shining example of what we can achieve when curiosity and reason work together. Neptune is often described as the blue jewel of the solar system, a world that glows with a rich, sapphire hue unmatched by any other planet. This mesmerizing color is not just a visual delight, but a clue to the very chemistry of the planet's atmosphere. Neptune belongs to the category of ice giants, along with its near twin Uranus. These planets differ from the gas giants, Jupiter and Saturn, in that they contain a greater proportion of ices, water, ammonia, and methane, mixed with hydrogen and helium. This unique composition makes Neptune not just another gas ball in space, but a fascinating laboratory for planetary science. At a diameter of about 49,244 kilometers, Neptune is the fourth largest planet in our solar system. It may seem smaller compared to Jupiter and Saturn, but Neptune's sheer size still dwarfs Earth. In fact, more than 57 Earths could fit inside Neptune's volume, and its mass is 17 times greater than our own planets. Despite this, Neptune has a lower density than Earth, reflecting its icy and gaseous makeup. A human who stood on Neptune, if such a feat were possible, would experience a gravitational pull about 1.14 times that of Earth, making it slightly heavier to walk but still recognizable compared to our home planet. Yet Neptune's true identity lies in its atmosphere, a dynamic and violent layer of gases that swirl with unimaginable force. The atmosphere is made primarily of hydrogen, about 80%, and helium, about 19%, with a trace of methane making up less than 2%. But it is this tiny fraction of methane that paints the planet blue. Methane molecules absorb the red and orange wavelengths of sunlight, scattering back the blue, giving Neptune its dazzling ocean-like appearance. Unlike Uranus, which also contains methane but appears a pale cyan, Neptune's blue is far more vivid, suggesting that additional unknown factors, perhaps trace atmospheric compounds or deeper cloud structures, enhance its brilliance. Beneath the stunning exterior lies chaos. Neptune is home to the fastest winds in the solar system. Jet streams rage through its atmosphere at speeds of up to 2,100 kilometers per hour, faster than the speed of sound. These supersonic winds are not just impressive numbers, they are forces of nature that sculpt massive storms across the planet's gaseous layers. One of the most famous of these was the Great Dark Spot, discovered by NASA's Voyager 2 spacecraft in 1989. Comparable in size to Earth, this storm was a swirling vortex of high-speed winds and dark clouds, a cousin to Jupiter's Great Red Spot. But unlike Jupiter's storm, which has lasted for centuries, Neptune's Great Dark Spot vanished within a few years, replaced by new storms elsewhere on the planet. This reveals a key truth about Neptune. It is a restless world, where storms are born and die quickly, where nothing is permanent, and where the atmosphere is in constant motion. The layers of Neptune's atmosphere are structured much like an onion. At the very top lies a thin haze of hydrocarbons and icy crystals. Beneath that is a thick layer of clouds composed of methane ice, ammonia, and hydrogen sulfide. Deeper still, the atmosphere transitions into a superheated ocean of water, ammonia, and methane, an exotic state of matter often described as slush or hot ice. Scientists believe that under the immense pressures inside Neptune, water molecules are crushed into crystalline structures that remain solid despite extreme heat, creating a bizarre ice that burns at thousands of degrees. This transition from gas to exotic ice leads down into Neptune's mysterious interior. Unlike Jupiter and Saturn, which are thought to be composed mostly of hydrogen and helium throughout, Neptune's core is believed to be made of rock and metal surrounded by a thick mantle of water, ammonia, and methane ices. This dense, icy mantle makes up the majority of the planet's mass and distinguishes Neptune as an ice giant rather than a classic gas giant. At the very heart lies a rocky core, likely similar in mass to Earth, compressed under unimaginable pressures. Temperatures here may soar to 7,000 degrees Celsius, hotter than the surface of the sun. One of Neptune's most puzzling mysteries is its energy output. Despite receiving less than 3% of the sunlight that Earth enjoys, Neptune radiates 2.6 times more energy than it absorbs from the Sun. This excess heat suggests an internal energy source, possibly residual heat from the planet's formation or the slow release of gravitational energy as heavier materials sink toward the core. Whatever the cause, it fuels Neptune's turbulent atmosphere, driving its violent winds and shifting storms. In a sense, Neptune's blue clouds and raging winds are powered not by the distant sun but by the planet's own inner fire. To imagine standing near Neptune's surface, if one existed, is to imagine standing in the middle of a nightmare storm. Winds scream across the horizon, carrying clouds of methane ice that shimmer faintly in the dim sunlight. The faint glow of the distant sun is barely brighter than twilight on Earth, and the planet's deep blue hues give the sky a surreal, oceanic glow. There are no solid surfaces to walk upon, only endless layers of cloud and liquid-like gases, stretching down into crushing depths where light cannot penetrate. And yet, in this alien chaos, there is beauty. The planet's atmosphere, with its ever-changing spots, bands, and streaks, is a canvas of cosmic art. Sometimes, white methane ice clouds appear high above the darker layers, racing across the sky like wisps of smoke against sapphire seas. These clouds, reflecting what little sunlight reaches Neptune, gleam like diamonds in the darkness, offering fleeting glimpses of wonder in a world of storms. Neptune's physical characteristics remind us that planets are not static or uniform. They are alive with forces beyond our comprehension. From its glowing blue atmosphere to its raging winds and exotic interior, Neptune is a symphony of extremes, a planet that thrives at the very edge of the sun's warmth yet refuses to be silent or still. Its storms may vanish quickly, but they reveal a truth about the universe. Even in the farthest, coldest places, energy, motion, and mystery reign supreme. If Neptune's atmosphere reveals its outer beauty, then its rings and moons tell the deeper story of its past, its violent encounters, and its role as a sculptor of the outer solar system. Though often overshadowed by the dazzling rings of Saturn, Neptune's ring system and its unusual collection of moons are no less remarkable, offering a glimpse into a history shaped by capture, collisions, and the relentless tug of gravity. Before exploring its moons, it is worth pausing at Neptune's magnetic field, a phenomenon as strange and unbalanced as the planet itself. Unlike Earth, where the magnetic poles roughly align with the planet's rotation, Neptune's magnetic field is wildly tilted, lying at an angle of nearly 47 degrees relative to its axis of rotation. Even more peculiar, the magnetic field does not emerge neatly from the planet's center but seems offset by nearly 13,500 kilometers, more than half of Neptune's radius. This bizarre configuration suggests that Neptune's magnetic field is generated not in its deep core, as Earth's is, but in the outer layers of its icy mantle, where ionic slushes of water, ammonia, and methane churn under high pressure. The result is a lopsided, shifting magnetic field that wobbles dramatically as the planet spins, creating regions where magnetic forces are far stronger or weaker than expected. Voyager 2's flyby in 1989 revealed this peculiar magnetism, raising questions about the stability of such a tilted field and whether it may fluctuate over geological time. For any spacecraft orbiting Neptune, this tilted magnetosphere would create a constantly changing environment, bathed in streams of charged particles and radiation belts that dance unpredictably. To scientists, Neptune's magnetic field is a reminder that planets can rewrite the rules we take for granted, showing us that even the invisible forces of nature can surprise and confound. Encircling Neptune are faint, fragile rings, subtle structures that were first suspected in the 1960s when starlight passing behind Neptune appeared to flicker, as if blocked by thin bands of material. It was not until Voyager 2's visit in 1989 that these rings were directly imaged, confirming that Neptune, like its giant siblings, was adorned with a ring system of its own. Neptune's rings are far less prominent than Saturn's shimmering bands or even Jupiter's faint halo. Composed primarily of dust and icy particles, they are dark, likely coated in radiation-processed organics that absorb sunlight. There are 5 principal rings, each named after astronomers who contributed to Neptune's discovery: Gall, Leverrier, Lassell, Arago, and Adams. Among them, the Adams ring is the most intriguing. It contains a series of mysterious bright clumps known as arcs, which defy the expectation that particles should spread evenly around the ring. These arcs, named Liberty, Equality, and Fraternity, remain bunched together despite the spreading forces of gravity and orbital motion. Scientists believe that the gravitational influence of a nearby moon, Galatea, shepherds these arcs, corralling the particles into tight clusters. This delicate dance between moon and ring reveals the hidden forces shaping Neptune's system, where gravity acts like an invisible artist sculpting dust into patterns. Though faint, Neptune's rings remind us that beauty does not always shine brightly. Sometimes, it hides in ghostly shadows, whispering secrets about shattered moons and cosmic collisions long past. Neptune's family of moons is as diverse as it is dramatic, with at least 14 confirmed moons ranging from small, irregular fragments to Triton, a world that rivals Pluto in size and intrigue. Each moon tells part of Neptune's story, whether through chaotic orbits, icy surfaces, or origins that trace back to the solar system's earliest days. The smaller moons, such as Naiad, Thalassa, Despina, and Galatea, are irregularly shaped, battered by impacts, and locked in tight orbits close to the planet. Many of them act as shepherds for Neptune's rings, stabilizing the arcs and edges through gravitational resonance. Further out, moons like Nereid follow eccentric, elongated paths, suggesting that they may have been captured from elsewhere or disturbed by a violent event in the past. But towering above them all is Triton, Neptune's largest moon and one of the most captivating objects in the entire solar system. Discovered just weeks after Neptune itself in 1846, Triton is a world of contradictions and mysteries. At 2,710 kilometers in diameter, it is nearly as large as Earth's own moon and larger than Pluto. Unlike most major moons, which orbit their planets in the same direction as the planet's rotation, Triton travels in a retrograde orbit, circling Neptune in the opposite direction. This unusual path strongly suggests that Triton did not form alongside Neptune but was instead captured from elsewhere, possibly a Kuiper Belt object that wandered too close and was ensnared by Neptune's gravity. Triton's capture would not have been a gentle event. Its arrival may have disrupted Neptune's original moons, scattering or destroying them in violent gravitational interactions. Some scientists believe that the debris from these shattered moons may now form part of Neptune's faint ring system. Triton, then, is both a survivor and a conqueror, a cosmic wanderer that found a new home but at a terrible cost to Neptune's original companions. Yet Triton is far more than a captured relic. It is an active world, alive with processes that continue to this day. When Voyager 2 flew past in 1989, it revealed a surface unlike any seen before. Instead of being heavily cratered like most moons, Triton's landscape was young and dynamic, with vast plains of frozen nitrogen, ridges, and strange, cantaloupe terrain, marked by dimpled patterns. Even more astonishing were the geysers, plumes of nitrogen gas erupting kilometers into space, driven by the heating of subsurface layers. These active geysers make Triton one of the few bodies in the solar system, alongside Earth, Io, and Enceladus, with observed cryovolcanic or volcanic activity. Beneath its icy crust, scientists suspect that Triton may harbor a subsurface ocean, kept liquid by tidal forces from Neptune's gravity and radioactive decay in its interior. If true, Triton could be another potential cradle for microbial life, a frozen moon hiding a liquid ocean in the darkness of the outer solar system. In this way, Triton mirrors moons like Europa and Enceladus, standing as a beacon for astrobiological exploration. But Triton's future is as dramatic as its past. Because of its retrograde orbit, Triton is slowly spiraling inward toward Neptune. Astronomers predict that in about 3.6 billion years, Triton will pass within Neptune's Roche limit, where tidal forces will tear it apart. When that day comes, Neptune may gain a spectacular new ring system, rivaling Saturn's in grandeur, a cosmic reminder that even destruction can give rise to beauty. Together, Neptune's rings and moons form a system of constant motion and quiet drama. The rings, faint but sculpted, speak of collisions and moonlets shepherding dust into place. The small moons, irregular and battered, bear witness to a turbulent history. And Triton, the captured wanderer, stands as a testament to the gravitational reach of Neptune and the chaotic ballet of the solar system. Neptune is not a solitary giant at the edge of the solar system. It is the heart of a complex family, each member contributing to its identity, each moon and ring whispering part of the tale. To study Neptune's magnetic field, rings, and moons is to listen to the planet's voice, sometimes soft, sometimes violent, but always filled with mystery. When we think of Neptune, it is easy to see it simply as the last of the giant planets, a blue sentinel standing at the edge of the Sun's visible family. But Neptune is far more than just a boundary marker. It is a cosmic architect, a gravitational guardian, and a key player in shaping not only its own region of space, but the entire architecture of the solar system. To understand Neptune's role is to uncover the deep, interconnected story of planetary migration, orbital resonance, and the icy frontier known as the Kuiper Belt. Neptune's mass, while smaller than that of Jupiter or Saturn, is still immense, 17 times greater than Earth. This gravity acts like a sculptor's hand, influencing the orbits of countless smaller bodies in its vicinity. Beyond Neptune lies the Kuiper Belt, a vast disk of icy objects that stretches billions of kilometers into space. This region, home to dwarf planets such as Pluto, Haumea, and Eris, is directly shaped by Neptune's gravitational reach. Many Kuiper Belt objects, KBOs, are caught in orbital resonances with Neptune. For instance, Pluto and several other bodies belong to what is called a 2:3 resonance. They complete 2 orbits around the Sun for every 3 orbits of Neptune. This gravitational dance ensures stability, preventing close encounters even though Pluto's orbit crosses that of Neptune. Without such resonances, Pluto's orbit might have long since become chaotic or unstable. In this way, Neptune is like a conductor in a cosmic symphony, keeping time for the smaller icy worlds beyond. Its pull maintains order in what might otherwise be a chaotic scattering of objects. Neptune's influence extends so far that astronomers believe it also shaped the early migration of planets, pushing and scattering smaller icy bodies across the solar system. The idea that the giant planets have not always been where they are today is one of the most fascinating theories in modern astronomy. Known as the Nice model, after the city in France where it was developed, this theory proposes that billions of years ago, Jupiter, Saturn, Uranus, and Neptune migrated outward and inward, reshaping the solar system as they went. In this model, Neptune likely formed closer to the Sun than where it is today. Through gravitational interactions with Uranus and the other giants, it was pushed outward, settling into its current orbit at about 4.5 billion kilometers from the Sun. As Neptune moved outward, it disturbed the icy disk of planetesimals beyond it, scattering many into new orbits. Some of these became comets that carried water and organic materials into the inner solar system, perhaps even seeding Earth with the ingredients for life. Neptune's migration also explains the current structure of the Kuiper Belt, with its resonant populations and scattered disk objects. In a sense, Neptune is the gatekeeper of the outer solar system, its past motions leaving fingerprints across billions of kilometers of space. Without Neptune's gravitational shuffle, the Kuiper Belt, and even Earth itself, might look very different today. Though Neptune's storms and distance make it seem remote, its influence reaches inward. By deflecting and capturing comets and icy bodies, Neptune acts as a guardian for the inner solar system. Many long-period comets that we see streaking across the night sky originated in the distant Oort cloud, but before reaching Earth's skies, they often pass near Neptune, where its gravity alters their trajectories. Some are flung out into interstellar space, while others are nudged into new orbits that eventually bring them inward. This process makes Neptune a filter, reducing the number of potentially hazardous icy bodies that might otherwise collide with the inner planets. While Jupiter is often called Earth's protector because of its powerful gravity, Neptune plays a quieter but equally important role, shaping the cosmic traffic at the edge of the Sun's realm. Beyond Neptune lies one of the most intriguing regions of the solar system, the Kuiper Belt. This vast, icy wilderness is thought to be a relic of the early solar system, a frozen time capsule preserving materials from which the planets formed. The objects here range from tiny icy fragments to dwarf planets like Pluto and Eris, and their orbits tell a story that always leads back to Neptune. Many KBOs are locked in resonances, as with Pluto, while others have highly elongated or tilted orbits, the result of Neptune's past gravitational nudges. Some astronomers suggest that the peculiar distribution of certain distant KBOs may even hint at the presence of another hidden giant planet, often referred to as Planet 9. If such a world exists, Neptune would once again stand as a guidepost, marking the edge of the known and hinting at the unknown beyond. The Kuiper Belt is also significant because it represents the boundary of the Sun's influence, where the giant planets end and the icy small bodies begin. Neptune, sitting right at the inner edge, is like a sentinel at the gateway, a marker between the world of planets and the realm of icy remnants. Without Neptune, the border between planet and belt would be blurry and unshaped. With Neptune, it becomes a structured frontier. Understanding Neptune's role in the solar system also has broader implications. By studying how Neptune interacts with its surroundings, astronomers gain insights into planetary systems around other stars. Many exoplanets discovered so far are Neptune-like, intermediate in size between Earth and Jupiter, with thick atmospheres and icy mantles. In fact, these Neptune-like worlds appear to be the most common type of planet in our galaxy. By studying our own Neptune, we gain a model for these countless alien worlds, helping us understand how planets form, migrate, and evolve. Neptune's storms, magnetic field, rings, and gravitational influence all serve as clues not just for our solar system, but for planetary systems across the cosmos. In this way, Neptune is both local and universal. It is the farthest major planet from our Sun, yet its lessons echo across the galaxy, reminding us that the forces shaping our solar system are the same forces at work in countless star systems beyond. Neptune's place in the solar system is not just scientific, but symbolic. For centuries, humans have looked to the sea as the edge of the known, a frontier to be crossed in search of discovery. By naming the planet after the Roman god of the sea, astronomers gave it a role that mirrors history. Neptune is our cosmic ocean, the final great giant before the icy wilderness, a symbol of the human spirit's drive to venture beyond what is familiar. To study Neptune is to look outward toward the edge of the sun's light and to recognize that boundaries are not limits but invitations. Just as ancient sailors once launched their ships beyond the horizon, we too dream of sending spacecraft beyond Uranus and Neptune into the Kuiper Belt and onward to the stars. For all its grandeur, Neptune remains a stranger to us. Unlike Mars, where rovers roam the dust, or Jupiter and Saturn, which have been orbited by dedicated spacecraft, Neptune has been visited only once in human history, and that fleeting encounter left us with more questions than answers. In the summer of 1989, NASA's Voyager 2 spacecraft swept past Neptune, giving humanity its very first close-up view of the distant ice giant. That brief flyby was a moment of triumph, one that transformed Neptune from a dim blue in telescopes into a living world of storms, rings, and dynamic moons. Launched in 1977, Voyager 2 was part of NASA's ambitious plan to take advantage of a rare planetary alignment, one that allowed a spacecraft to use the gravitational slingshot of multiple planets to tour the outer solar system. After visiting Jupiter in 1979, Saturn in 1981, and Uranus in 1986, Voyager 2's grand journey brought it at last to Neptune. On August 25, 1989, it made its closest approach, passing just 4,950 kilometers above Neptune's north pole and skimming only 40,000 kilometers from Triton. The images sent back stunned the world. For the first time, We saw Neptune's atmosphere in detail, brilliant blue hues streaked with high-altitude white methane clouds. Voyager 2 captured the now-famous Great Dark Spot, a storm the size of Earth, swirling with unimaginable power. It revealed winds roaring at supersonic speeds, confirming that Neptune was a restless, energetic world. The spacecraft also uncovered Neptune's faint, dusty rings, confirming decades of speculation, and gave us our first close look at Triton, where geysers of nitrogen gas sprayed into the thin atmosphere. For planetary scientists, Voyager 2's flyby was nothing short of revolutionary. In a single encounter, it doubled humanity's knowledge of Neptune and Triton. But like a fleeting meeting with a stranger, it also left behind a sense of incompleteness. Voyager 2 sped onward into interstellar space, leaving Neptune behind, and in the decades since, no spacecraft has returned. Why, then, has Neptune not been revisited? The answer lies in distance. At more than 4.5 billion kilometers from the Sun, Neptune is 30 times farther from our star than Earth. Even at the speed of modern rockets, a journey to Neptune would take more than a decade. Voyager 2 itself took 12 years to make the trip. Any mission designed to orbit Neptune, let alone land a probe on Triton or plunge into the atmosphere, would face daunting technological challenges. The cold, harsh environment also poses difficulties. Spacecraft instruments must endure extreme cold, limited sunlight, and long communication delays. A radio signal from Earth takes over 4 hours to reach Neptune, meaning that spacecraft must operate with significant autonomy. Power is another hurdle. Solar panels are ineffective at such distances, so missions must rely on nuclear energy sources, which are expensive and limited in availability. Yet despite these challenges, the scientific rewards are immense. Neptune remains the least explored of the giant planets, and its mysteries, its supersonic winds, tilted magnetic field, interior heat, and active moon Triton, beckon like unanswered questions at the edge of a test paper. In recent decades, scientists have put forward several mission concepts for Neptune exploration. Some envision an orbiter that could circle the planet for years, mapping its atmosphere, rings, and moons in exquisite detail. Others propose a Triton lander or probe designed to explore the icy surface and search for signs of a hidden ocean. Still others dream of an atmospheric entry probe, much like the one deployed at Jupiter by the Galileo mission, which could plunge into Neptune's clouds and directly measure their composition. One particularly ambitious concept is the Neptune Odyssey mission, proposed as a flagship-class mission for NASA's future planetary program. This spacecraft would use advanced propulsion and nuclear power to orbit Neptune for a decade or more, deploying probes into the atmosphere and performing multiple flybys of Triton. Scientists argue that such a mission would not only unlock Neptune's secrets, but also provide insights into exoplanets, since many Neptune-like worlds have been found around other stars. Meanwhile, the European Space Agency has considered concepts like OSS, Outer Solar System Mission, and international collaborations that could share the cost and expertise of such a daunting mission. Although no Neptune mission has yet been approved, the growing interest in ice giants, especially after the success of Cassini at Saturn, has rekindled hope that Neptune may one day receive the attention it deserves. Exploring Neptune is not simply about adding another world to the list of places visited. It represents a leap forward in understanding planetary science as a whole. Neptune and Uranus occupy a unique category of planets, the ice giants, that differ fundamentally from Jupiter and Saturn. Because Neptune-like planets appear so common in the galaxy, understanding our own Neptune gives us a window into the most widespread type of world in existence. Moreover, Neptune's active moon Triton may be one of the most promising locations for finding life beyond Earth. With its suspected subsurface ocean and observed cryovolcanic activity, Triton could host environments where microbial life might survive, protected beneath its icy shell. A mission to study Triton up close could therefore answer questions not only about Neptune's system, but also about the universality of life in the cosmos. Finally, there is the human spirit of exploration. Neptune, as the farthest giant planet, represents the outer edge of the Sun's known dominion. To send a spacecraft there is to push human technology, ingenuity, and imagination to the limit. It is to affirm that no frontier is too distant, no mystery too deep for us to chase. Even now, decades after Voyager 2's flyby, the images of Neptune and Triton remain iconic. They are postcards from a frontier we have only glimpsed once, reminders of how vast and unexplored our solar system still is. Each time scientists or space enthusiasts look at those images, the azure storms, the ghostly rings, the nitrogen geysers, they are reminded of a truth: we have unfinished business with Neptune. Someday, perhaps in the coming decades, a spacecraft will once again cross the immense gulf and settle into orbit around this mysterious blue giant. When that day comes, we will not only rewrite our textbooks but also reaffirm the very essence of exploration, that to know the universe, we must venture into its most distant, forbidding, and beautiful corners. At the edge of our solar system, where sunlight dwindles into the faintest glimmer and space stretches into infinite darkness, Neptune waits, silent, powerful, and eternal. It is a planet of paradoxes, a frozen world that burns with internal heat, a place of storms more violent than any on Earth, a realm so distant that it seems unreachable, yet so captivating that it calls to us with irresistible force. Neptune is not just a planet of science, it is a planet of wonder, of imagination, of dreams that pull us toward the stars. From the moment it was discovered through mathematics in 1846, Neptune has symbolized the brilliance of human intellect. Unlike the bright planets visible to the naked eye since antiquity, Neptune was hidden, veiled in distance and darkness. Yet we found it, not by sight, but by reason, calculation, and persistence. This discovery was not only a triumph of astronomy, but also a profound reminder that humanity's greatest tool is its mind. We are not bound by what our eyes can see. We are propelled by what our minds can imagine. Neptune's beauty is undeniable. Its deep sapphire blue atmosphere, sculpted by methane and sunlight, is unlike any other planet in the solar system. Its clouds drift like ghostly brushstrokes across its face, while massive storms whirl with ferocity unmatched on Earth. It is a painting in motion, a living masterpiece crafted by physics and time. To gaze upon Neptune is to glimpse the raw power of nature at its most majestic, a cosmic ocean where winds scream faster than sound itself. And yet Neptune is more than its storms. Its tilted magnetic field, faint rings, and diverse moons remind us that even in the farthest reaches, complexity thrives. Triton, Neptune's captured moon, spins backward in defiance of celestial order and erupts with geysers of nitrogen gas. It is a world that may conceal a subsurface ocean, a place where the seeds of life could exist in hidden darkness. In Triton, Neptune holds a tantalizing clue about the possibilities of life beyond Earth and about the chaotic, dynamic processes that shaped our solar system. Neptune also plays a guardian's role, quietly shaping the outer solar system. Its immense gravity sculpts the Kuiper Belt, corrals icy bodies into stable orbits, and influences comets that occasionally fall inward toward the Sun. Without Neptune, the balance of the outer solar system would be different, and Earth itself might have faced a more dangerous cosmic environment. In this way, Neptune is both mystery and protector, a giant whose unseen hand helps maintain order at the edge of chaos. Our exploration of Neptune so far has been brief, a single encounter with Voyager 2 in 1989. Those images of the Great Dark Spot, of wispy methane clouds, of Triton's icy plains, remain some of the most hauntingly beautiful ever captured. But they are only a first chapter. Humanity has unfinished business with Neptune. Missions to return, to orbit, to land, are dreams not yet realized but constantly imagined by scientists and explorers. Someday, we will go back. And when we do, the discoveries we make will reshape not only our understanding of Neptune, but of planets across the galaxy, for Neptune-like worlds are among the most common in the universe. To speak of Neptune is also to speak of ourselves. In every storm it holds, we see the turbulence of curiosity. In every ring and moon, we see the persistence of complexity. Neptune reminds us that the universe is vast and uncharted, that there are still frontiers untouched by human hands, waiting for the courage of exploration. It teaches us humility, showing us how small we are in the face of cosmic forces. But it also fills us with pride, for we are a species that dares to seek, to wonder, and to understand. And so, Neptune stands as both destination and symbol. Destination, because one day our spacecraft will return to orbit its blue expanse, sampling its atmosphere, probing its magnetic mysteries, landing on Triton's frozen crust, and maybe even searching for life beneath. Symbol, because Neptune embodies the very essence of exploration, the belief that no distance is too far, no challenge too great, no mystery too deep for human curiosity to pursue. In the grand story of the solar system, Neptune is not an afterthought, not merely the last stop on the planetary list. It is a world of storms and silence, of beauty and power, of questions that stretch our science and imagination. It is the cosmic reminder that the universe will never run out of wonders, only out of those willing to chase them. When we look at Neptune, a glowing blue jewel suspended in the dark, we are reminded that the edge is never the end. It is only the beginning of what lies beyond.